Alright, so we're going to touch off, and then we'll go ahead and crank in about 50 at a time, I guess, until we get down to size. Set my 0. Crank it 50. This is pretty soft material. This is a good sharp cutter. I could probably take 100 at a time if I really wanted to. But this is good. I'm getting a nice smooth cut. So I'd rather take my time and do a few passes rather than push it. So there's 50. Extra 150. Let's just do a quick sanity check here. Looking good. Smoke is from a bunch of old grease and grime that was left in the threads that were from that original part. I think I miscounted here because I'm right at the edge of the hole there. I have a feeling I might have cranked in 100 instead of 50 on one of those cranks. That's what I get for trying to talk to the camera and work on the part at the same time. Let's just check this and see how it looks. Well, I got a big old burr on there. Let me grab a file and knock that off and let's take a look at it. Be right back. Alright, so as I suspected, I was busy yapping here and wasn't paying attention to my numbers. The good news is I did not overshoot it. I got a little bit to go here, so I went ahead and set the indicator back up again. 0 on my original here. We'll crank the table over. And I've got about, 17 and a half. 17 and a half, 17. All right, we're going to take 17, and that should be pretty much right on the money. So let's go ahead and get the indicator out of the way, and we'll take 17. Okay, raised to table 17th thou. I went ahead and locked the knee firmly. I'm going to go ahead and crank the speed up on this a little bit just to try for a nice smooth finish. And hopefully this will be the final dimension side to side in this part. Then we just got to flip it over and take it down to 50 thousandths the other way. All right? Bump that in a little bit, just to get a little bit less of a burr on the side if I can. That's looking pretty good. Alright, so I'm just through on the thread here, which is fine because that's obviously going to get cut off here. And on the original part, you know, it sort of tapers down pretty much to nothing where the thread is. So I think this is going to be good. Take it out, give it a deburr, and then we'll check our dimensions and we'll check the fit in the carrier that it goes into. Alright, so I ended off a little off center here. Looks like maybe 15 or 20 thousandths, but that's going to be fine. This is not super critical. Like I said, the lead screw in this machine is kind of worn anyway, so there's going to be plenty of leeway there. Important thing is that it fits well and moves well inside the part. So this is the carrier that it rides up and down in. And that's basically the movement that it makes is up and down this way. And that's about perfect. There's maybe a couple thousandths of play in there. Oh, my hand's right in the way, you can't see that. So that's basically it. No, actually it's going to end up going in. Well, that's about as far as it comes down, maybe a little bit less than that. So this still needs to be trimmed up to depth here and to length. Obviously cut off that crummy stuff. I think what I'll do is I'm going to go ahead and get it squared up on the end here, but not cut into the thread. Mill the slot that goes in here. Right, so if you remember the original part here has this diagonal slot that actually drives it in and out, or up and down rather, onto the screw. So we'll go ahead and do that. Let me see if I have an end mill that's the right size for that. Otherwise I might take it over to the shaper and do it over there. So I think what I'll do maybe is whack the end off with a bandsaw and then clean up the end. All right, so let's do that and we'll come right back. All right, so I lopped off on the end of the bandsaw. Now I'm just going to take a couple of light passes here just to kind of get it cleaned up, and then I'll get it finished fairly close down to where the bore is there. This is going to be cut off more or less halfway across where that threaded hole is. So this is not a super critical dimension. Alright. So I got rid of most of the old crud from there. It looks pretty good. Good enough for now, at least. Like I said, this has more work to be done on it. So now I'm going to go ahead and we'll take it out of the vise. We'll flip it upside down, or flip it sideways rather, and start working on the thickness of the part. So I'm going to do that, and I will do that off camera to save you guys watching me drop my vise handle 3 or 4 times, and that'll be set up when you come back. Okay, so I measure my part, measure 770, target dimension, if you remember, so I've said it 100 times, is 500, so that leaves 270 to come off, so that's 135 a side, all right? So again, we're just going to probably take this off in 50 thousandths at a time. This time I'm going to actually pay more attention when I'm counting on the dial here to make sure I don't overshoot this. And that should be good for dimension, and then we'll move on to cutting the slot. All right. So touch off. And we'll take off 50 thousandths here. That's 50. This is a half-inch cutter. I should be able to actually get this across in one pass, so I'm going to set it up a little more carefully and try that again. So that's 50. That's 100. Let's see if I can get that in a single pass. If that's just not cleaning up, or if that's going to burn. Let's see if we can knock that off. Let's see what we get. All right, and the final 35. $10, 20, 30, 5, lock the table, Alright, let's take that out. We'll knock off the burrs, flip it over. And that left a wicked burr on there. You can't see me, can you? Alright, how about that? Maybe I'll look for one of my little carbide deburring tools. It might be faster than using a file. Let's take it down. Alright, that feels pretty good. I guess I could have taken all that all off of one side, since it doesn't really matter. Well, a little late for that, so we'll go ahead and we'll take off another 135. Let's see which side is a better finish. Actually, this side looks better, so we'll put that side down, and then we'll take off another 135, and that should be down to my final dimension. Alright. $50. 100. Go ahead and crank the speed up a little higher. This probably puts me at about 1800 RPM, somewhere around there. And that's it, part's the size. Alright, so this part's still on the vise, I haven't taken it out yet. I don't know if you can see that the finish on there is real nice. A couple of minor little marks on there, but all in all, I think that'll be just good. It's, you know, that face is just resting on the back of the little carrier there. So I may go ahead and take some fine sandpaper and just polish it up, or maybe take it to my polisher. But that's that. So now we got to go ahead and figure out how to cut that slot. I don't have a swivel vise mounted on this machine. I guess I could grab one off of another machine and get it mounted and trimmed and do it that way. That's probably going to be my best bet, rather than try to mess around with you know, putting some kind of angle blocks in there or something like that. So I could also, well, let me think about that. I got a couple of swivel vices. Maybe let me see what I can find and see what makes the most sense. So I'm going to sort that out for a bit, do some thinking, and then we'll cut that slot. Okay, so I found a swivel vise. I thought I had a couple of them, but actually this is the only one I have. I just picked this up about a month ago at a machine shop sale, so guess I'm glad I did. I think I paid 10 bucks for it. It's a pretty nice heavy vise. No markings on it or anything. I do need to make a handle for it, so right now I'm just using this 7/16 wrench. So I was sitting here for a little while pondering on how I'm going to get this lined up so I can mill this groove in the proper orientation. So what I decided to do was I took a pin that's just about the width of the slot here, and I just put it in a collet, and then I got the vise kind of turning free here. And what I did was I just brought it up and just kind of put the table just over with a little bit of pressure on there. Actually, I should probably lock this down a little bit snugger here. I don't want it too snug. So we'll just go ahead and kind of bump that in. And then I'm going to run the table back and forth a few times. And now I'm dragging on one side. And I think that's going to get me pretty close. So I'm going to snug the vise up just a little bit. Then I'm going to go ahead and take my pin out, and I'm going to put my test indicator on the side of the face there and run the table back and forth a little bit and see if I can measure how close that is. Again, I don't need this to be within, you know, a 10,000th or anything. There's a little bit of free play on the pin that rides in there. It's just driving this thing up and down. It doesn't have to be precisely set, but I want to get it reasonably close. So I'm going to lower the table down so I can put my my Noga on the face of the column here, and then we'll go ahead and indicate that out, and let's see how close we can get it. So let me grab my Noga and let me grab a test indicator, and we'll get set up for that. Okay, so my Noga was too big to really get in here and get that set up, so what I'm using instead, I call this my Hell No Ga. This is a $5 articulated arm that I picked up at a yard sale. It came with a really crappy Chinese indicator on it, but it's not too terrible. Once you snug it up, it actually holds pretty good. It's a little floppy when you loosen it up, unlike the Nogas where you have a little more flexibility, but it's going to definitely do the job. So I got it set up here, so I'm just going to go ahead and crank this in. Whoop! This is a tense indicator, so it's a little bit on the sensitive side, obviously. Whoop! That's really touchy. Alright, so that's about 0. And then I'm just going to go ahead and bring the table forward. And I can see already that I'm a little ways out here. I guess I'm past my travel here. Perhaps I would have been, you know what I'm going to do? I'm going to stop. I'm going to go ahead and get a thousandths indicator and use that, and then if I feel like, maybe I'll go ahead and true it up with the tenths just to get it right on. So let's swap indicators and we'll try that again. All right, this should be a little easier. This guy's got a 15th out travel on it, so I'm kind of right at the edge here. I'll sort of set it on 0 and we'll start moving across here. All right, so I can see already the back is going to be a little bit high. So I'm just going to maybe, did I lose contact? Maybe I did. I'm going to bring the knee down just a touch. I'm kind of dragging on the edge of the arm there. Looks a little better. All right, looks like I'm way out of there. Let's try that. Getting there. I don't think the inside of that is perfectly smooth, but all right, so that's within a couple of thou. I'd say that's pretty close. So I think I'm going to go with that. Measured the slot. So I got a 3/16 end mill. That's pretty good fit in there. I'd probably take a few thou off either side to make a good fit on that. So let's get that set up. I'll get the indicator out of the way. I'll make sure this is locked down nice and tight in the vise. Before I forget and do anything, I'm going to snug down the swivel on that vise. Where's my Allen wrench? I probably dropped it like I do with everything. So get everything squared away here, get it all snug and tight, and we're going to go ahead and make that slot. All right? We've got to remember to match the depth too. Okay, so I needed to lay out the location of this slot relative to the end where the threads are. All right, so, and I know these threads are worn, so I want to actually have this other part extend down a bit further than this one, so it doesn't need to be ultra precise because I'm just kind of taking a guess as to how much wear is really on here. So what I did was I laid down my part here on a piece of paper with a cross here, and I just lined it up so that I could just see the vertical line here in the end of the thread part here. Then I took my other piece and I just lined it up against the line, and then I pushed it down, I don't know, maybe a 64th of an inch or so, and then I just clamped them together. I took a square and I just transferred the location of those lines. I flipped it over, I transferred the location of the slot on the other side, took the square, brought my lines to the top just by eye again, and that's the location on my slot. And if I just kind of line it up, where am I here? By hand, or by eye rather, I can see that I'm pretty much right on there, where I want to be at least. Like I said, I want this one extending down a bit further than the other one because that was the problem in the first place, was there wasn't enough engagement on these threads. So that's what I'm going to do. That's the slot I'm going to cut, and then all I got to do is cut it to length, whack the end of this part off so that the only the half the thread is there, and then we'll install it in the holder and hold our breath. Okay, so I measured the depth of the slot here using my digital calipers, and it looks like it's about 219, 218 or so, give or take. You know, again, this is an old machine. It's got some wear, so this is not perfectly even. I'm getting just about 219. So I guess 219 is probably a good a number as any for this. So I've got my part centered up on the cutter. I'm going to go ahead and raise the table and touch off, and then we'll just take a light cut just to kind of check the alignment, make sure everything in there looks good, and then if that looks all right, we'll go ahead and bring it down to depth. So I'm going to back out. Actually, I'm going to go ahead and... This is a pretty small cutter, so I'm going to go ahead and really crank up the speed. I'm going to touch. I'm going to set 0, just so I don't lose my bearings. Okay, now we'll take the other part, the original part here, and we're just going to kind of line it up, give it a sanity check, make sure nothing looks crazy, and that looks pretty good. Alright. So here we go. This is a pretty small cutter. I'm just going to go ahead and probably take maybe 30 thousandths, see how it does, and maybe go a little bit more from there, see how it ends up doing. So there's 10, 20, 30. That's pretty good. 30 more. This is a small cutter. I'm afraid I don't want it to bind up in that slot at all. I'm just going to go ahead and get a little bit of lube. Normally I'll cut brass just dry for most stuff, but for an operation like this, a little juice can't hurt. Alright, so 10, 20, 30 more. What I think I'm going to do is clean this up a little bit. I'm going to grab the part that actually rides in this and just kind of check it for fit and see if I'm going to need to go a little bit side to side to make that groove a little bit wider. So let me go dig that part out and hit this with a file real quick, and let's see how it's looking. All right, so I cleaned it up with a file. The side of the cut on this side is a little rough. So I think what I'm probably going to end up doing is going ahead and getting this down to the right depth, and then I'll bring the table over just maybe 2 or 3 thousandths that way, and just kind of give it a clean up. I don't know, this is a pretty sharp end mill, but it's not leaving a particularly good finish on that end of the cut. So this is the pin, can you see that? This is the pin that engages into the slot. And if I keep pressure on it on that side of the cut rather than this side, it runs pretty good. So it's going to need a little bit of cleanup and everything, but I think it's going to be fine. So it's actually, the slot on the original part is quite a bit deeper than it needs to be to engage that pin. You can see there's, can you see that? Oh, wrong way. There's quite a bit of clearance on the bottom of that. So let's just check the depth on this and see where we're at. I'm going to check this one too. I believe my number was 220. And it is. And of course everything's in the way here. Well, that's all right. I'm about 175 here, so take another 25. Bump the camera while I'm at it. There's 10, 25. Put a little juice on there, and off we go. Slow down, see if I get a better finish. I was feeding pretty aggressively there before. Actually looks a little better. Okay, so that should take me down to about 200. Let's just check the part here. Looks like it's still bottoming out, so we'll take another 20 off of that. Maybe I'll take it. Maybe I'll take 15 and then take 5 for a finish pass. So there's 5, 10, 15. Grab my magnifiers, put my big head in the way here. Still tearing out a bit on this side. Well, not particularly smooth on either side. Maybe I'm going a little too fast on this cutter. All right. Well, I got these. Let's eyeball the depth on that. That looks pretty good. I could actually stand to be a few thou wider, so I think what I'm going to do is I'm going to go ahead and take another 15 on the depth, and then I'm going to go ahead and crank the table a couple thou on either side and just try to clean up the edges of that. So all right. So now I'm going to go 2/1000 that way. think I was mostly taking out the backlash there, so let's just go a little bit more. Let's clean up a little better. Now we'll just touch the other side. I know, never use air in the shop. It blows chips into the machinery, it ruins everything, it causes cancer. Saves a lot of time though. All right, that's a much better, that's a good fit. It rides pretty smooth. There's still a few burrs in here. I'm pretty happy with that. I think that'll work well. It's not going to bind up. So let's go ahead and get that cleaned up, and then we will, I think I'm going to go ahead and cut this end to length, line it up with the other part, and then decide exactly where to chop it off on the end here. I think maybe what I'll do is what will I do? I think I'm going to go ahead and maybe grab the lead screw if I can fit it in here and just kind of get a feel for how that's fitting on there, and just kind of whittle away at it till I get. This is definitely less less than a half moon there, so I'd like to leave as much as I possibly can lengthwise on there so that it doesn't slip, but I also don't want it to bind up. So I'm going to go as close to half the circle as I can, and then we'll pop it together and keep our fingers crossed. Okay, so for length, I just took the original part. I just matched up the slot here, scribed the line by eye. This is just sitting in the top of the carrier here, so if it's, you know, a couple thousandths high or low, it's not going to make any difference at all. So I made my mark. It's not that I don't have any faith in being able to complete this part without completely screwing it up. However, I'm going to leave the other vise set up at the proper angle to cut the slot. I hate to think it, but just in case I completely destroy this one at some point here. So I've got my other end mill set up. I was pretty happy with the way this one was cutting. We're just going to go ahead and touch and just whittle away till I get to my line. And that's going to be that. I slowed the speed down a little bit, and that's going to be it. I got to come down a little bit in the table. I'm not quite catching the top of the flute there. Better? A little bit too much for that thing. You know, I had this pretty tight, and it looks like I'm actually lifting up a little bit in the vise. Maybe because I'm got it clamped on the edge here. This vise is kind of old. Maybe there's a bit of wear on there. So let's go ahead and get those parallels out of the way. I think what I'll do is I'm going to grab the other part and pop it on the other side of the vise just to put pressure a little evenly. Watch my head. See if I can do this without knocking the tripod over. We'll just drop that guy in there like that. Crank down on that guy real good. Alright, that feels good. Last pass. Okay, I lied. One more. Alright, that feels pretty good. So now, it will hopefully be the final thing. Oops. And that is going to be what have I done here? Am I too far down, or am I just losing my mind? No, there I go. So now I just want to make sure that I cut this off to the right depth. And now that I get it, I can see a little bit of tear out on those threads. What I think I'm going to do is I think I'm going to go ahead and bandsaw this just to kind of get it clear. I'll just go close to the end of the thread, and then I'll come back here. And what I think I'm going to try to do is, I don't want to bend this as I cut it. That's probably why it's done this way, because otherwise these little webs here on the end will be too thin. So let's saw it, and yeah, and then we're going to cut it. All right. Well, with any luck, this is going to be the final operation. I'm a little nervous about that. These are going to tear out and catch. It wasn't too happy on the bandsaw. It caught these edges here, but I'm not really quite sure what to do other than go for it at this point. So that's what we're going to do. And I see I'm going to hit the tripod here. Nope, I'm just clear. I'm not quite sure if slower is going to be better or faster is going to be better. I think what I'm going to do is I'm going to center up on the cutter as best I can. And I'm going to sort of plunge it in towards the cutter until I get pretty close. And then I'll set a 0 on my dial here in the end. And then I'll go ahead and back it out a little bit and do the same thing on the other side. I don't want to really be cutting across if I don't have to, because I'm afraid that that's going to tear this up. Maybe when I'm all done, I'll just take a one cross cut of maybe 1/1000. So, all right, here goes nothing. And I'm just going really, really slow here. I don't want to pull any chips off that are more than 1 thou or 2. other side, I ended up with not quite as much thickness on the end as I wish I had. So I think what I'm going to do is I'm going to leave this side as long as I dare, and the other side I'm just going to basically take down the minimum I need to. Alright, I think I'm happy with that. Now I'm going to come across to this side. And I'm just going to go and clean it up just till it's a little clean. Like I said, it's going to be a little uneven, but that should be fine. I'm pretty well centered on the cutter there. Well, I think I'm going to call that done. The insides of the threads, they look okay. They don't look brilliant on this side. I think what I'm going to maybe do is I'm going to take my original cutter and just by hand I'm just going to try to go through and just kind of clean up any little burrs in there. Just taking it nice and slow. So let me just drop the part and lose it after all that work, and then we'll start over again and make a new one. Okay, so I took a tool. I have some of these carbide threading tools that were in a box that I bought, and they've been started to be ground, but they have no relief at all on them. And I haven't got my tool and cutter grinder set up yet. I do have one, so they're not much use to me yet. So the threads were actually in much better shape than I thought. They were just full of a lot of chips. It looked like it was torn out. So I just took this by hand and just sort of ran it down each thread, cleaned it up real good, and took the part out, knocked all the burrs off, gave it a quick polish. So there's the original. There's the new one. They look somewhat similar, which is a good sign. So the next thing I'm going to do is go ahead and reassemble the part that this goes into with the carrier and try it out on the lathe. I'm scared. Are you scared? Let's go. Okay, so now we're going to assemble the whole shebang here. I thought I would film this, that way you guys can see me drop this ball bearing about 6 times and laugh at me. So it doesn't fit. So there's our first problem. All right, well, look at that. Guess what? I'm just going to check for burrs here. Well, it feels like it's just about, it's close, and it'll go if you force it, but obviously we want it to be a sliding fit. Back to the mill to take a few thou off each side. Okay, so here's my finished part. I did take a file and just cleaned up the inside of this. It felt like there was just a slightest little sort of burr on the edge here. So I just cleaned it up. It almost feels like the the bore where the lead screw rides also has just a little bit of an edge there. I'm not quite sure how to get in there and deal with that other than maybe just run the file through there one more time. But so I think and that actually feels pretty good. So I'm going to use a little assembly grease on this just to make sure things move good, and of course most importantly a little grease on the ball bearing, because otherwise there's no way that I won't drop that at least 3 times. Okay, so that moves pretty good in there. So that's somewhat encouraging to start. So I'll put a little grease in the hole there, and then we'll grab the spring. And my hand's right in the way, probably. I'm left-handed and I don't have room for the tripod on the other side, so. Alright, so the spring is in there. Another little dab of grease. Okay, here's the part where I dropped the ball bearing a whole bunch of times. If you hear a lot of beeping and bleeping on the video, you'll know why. Look at that. Not there yet, though. Still plenty of opportunities to drop it some more. All right, so now this guy goes in there. So before I greased it all up, I should have showed you. So I hope this shows up on camera. There's two little detents here that the ball bearing sits in that controls whether the lever's engaged or not engaged. This one was really kind of buggered up pretty bad. It was sort of ramped out so that it would just kind of slide past there. So I took a little die maker's chisel and I just kind of ticked away at the edge to push some metal up towards the detent. And then I took a ball end mill, the smallest one I had, which is a little bit bigger than this, and I just kind of cleaned up the hole a little bit. So I hope that's going to do the job. If not, I'm going to have to get a smaller ball end mill, or grind one, I suppose, and remake this part, which I'm not looking forward to because these pins are hardened, and I don't even know how they're attached. I guess they might be pressed in, although I don't see any evidence of them through the back. So anyway, let's keep going and hope for the best. So this guy goes in like this, engages the slot, and then the trick is to take your three hands, if I can remember how this goes. I guess it goes like that, and then you have to line up the lever, and there's a little washer here. The washer's got to be down. So if you engage that guy, and then without dropping the ball bearing, you slide that into place. And then there's just a single cap head that locks that guy in. Let's see if I happen to have the right one here. No, of course I don't. That's all right. It's probably over by the lathe. I'm just going to snug it down by hand. So this gets kind of held in place a little more firmly when the rest of these are affixed into the headstock. So, well, much as I hate to do it, so that's disengaged like that, and that had a pretty positive feel. And that's engaged, and I got lots and lots of material coming through that bore there. Let's see. I'm looking at this through the front of the viewfinder, so everything is backwards. So hopefully that's not too much, because then I'm out of luck. I guess I could probably try to either widen that slot. I could widen the slot and I could make a little bushing for the shaft on the handle if I really needed to, but I think that's going to be pretty good. I mean, this is not, driving anything under massive power. This is just hand feed. So I'm going to take this over to the lathe. I'm going to install it, and it's going to work. Okay, so the assembly is back on the lathe. When I went to go put the lead screw through it, I discovered that in the disengaged position like this, there was just a few thousandths coming down into the bore of the carrier here that was interfering with the lead screw. So I just took a round file, I went in there and I just cleaned it up a little bit just to make clearance. Again, this is a steel lead screw. It's a brass nut. It's going to wear a little bit anyway, so I wasn't terribly concerned. I put it all back together again. So this is disengaged. It runs just fine. You can hear it dragging on the lead screw just a tiny, tiny bit, but that's fine. Now the moment of truth. Throw the lever, and then we turn the hand wheel on the end of the lead screw, and the carriage moves back and forth just like it's supposed to. The detent is not all that positive, but that's not too surprising considering I had to mess with that, but it actually stays in place just fine. It doesn't have that good satisfying click like it does when it goes the other way, but it's not bad. So I'm going to call that a successful repair. It took a little longer than I anticipated, as these projects almost always do. I think this lathe is now basically in running order, so the next thing to do is to just give it a more thorough cleaning. We'll go ahead and get these castings all cleaned up, get rid of this crummy center, maybe polish it up. Just looking over here, I can see that the wiring on the motor sticking out here is a little crusty, so we'll address that either with a new cord, or we'll just lop that one off and reattach it. And then this machine is going to be back looking not quite as good as new, but pretty darn close. So thanks for watching. If you liked it, I hope you'll click the like button. If you haven't seen any of my other videos, I hope you'll check them out. And have a great night.